Today we are going to solve systems of linear equations by graphing. Systems of linear equations are just when you have two different equations and we're trying to find the solution to both of them. So when we graph this, this is the point where they intersect. All we are looking for today is the point of intersection. Now on this first example, I already graphed it for you. I graphed y equals 2x in green. My b was 0. My slope was 2, so I went up 2 over 1, up 2 over 1. For my purple line, I had a a y-intercept of 3, and I had a negative 1 for my slope, so I went down 1 over 1, down 1 over 1. Now my solution, or my answer to the problem, is going to be a coordinate. It's going to be where they intersect, so this black point right here. I would name my point as 1, 2. This is my answer. That's all we're looking for today. Now you can check your answers every single time. To check, all I'm going to do is plug in my answer to both equations. It has to work for both of them. So for y equals 2x, hang on. For y equals 2x, I have an x value of 1, a y value of 2. I get 2 equals 2 times 1, which is true, so that one works. We're good on that one. And then for y equals negative x plus 3, I get 2 equals negative 1 plus 3, which is also true. So we did it right. Now on this second example, I haven't graphed it yet. We have to graph it. So we should be very familiar with this. We've been using slope-intercept form for a while now. But for my first equation in green, I have a y-intercept of 0 because we're not adding anything to x. So my b is 0. I have a slope of negative 1, if my pen will let me write it. I have a slope of negative 1 because this is the same thing as negative 1 times x. So I'm going to go over here and plot my b at 0. I'm going down 1 over 1, down 1 over 1. So I'm going to graph this line in green. Should look like this. Alright, and then my second line, I have a y-intercept of 5. So my b is 5. And my slope is 3/2. So I'm going to start at 5. Since I'm running out of room, if I go down 3, then I have to go left 2 because this keeps my slope positive. And then I'm going to graph this one in purple. It looks something like this. So the point where they intersect would be right here, and we would name it as negative 2, positive 2. So my answer is negative 2, positive 2. And then we can check it. To check it, all I'm going to do is plug it in. You should check it every single time. I have y equals negative x. So 2 equals negative times negative 2, because over here negative 2 is my x, 2 is my y. And this is true because a negative times a negative is positive. And then on my second equation, I have 3/2 x plus 5. So I'm plugging in 2 for y and negative 2 for my x. My 2's cancel, and we get 2 equals 3 times negative 1 is negative 3 plus 5, which is also true. So they both work. Now, there are 3 different types of solutions you can get with systems of equations. You can get one solution where they intersect once. You could get no solution. This is where you have parallel lines, and we know from experience that parallel lines have the same slope. If you don't remember that, remember our algebra song. So an example of something that would be no solution is y equals 3x plus 1 and y equals 3x plus 5. They both have a slope of 3. So they are never going to intersect. You could also have infinitely many solutions, and that's when you have the exact same line. They intersect at every single point. This is going to look like this, where you have y equals 4x plus 2 and y equals 4x plus 2. They have the same slope and the same y-intercept. Now, the last part of this is going to be an example that you have to solve on your own. So in your notes, I want you to tell me the answer to this system. I've already graphed it for you. All you have to do is write down the point of intersection, and you're done.